Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 9, which is all about simplifying rational expressions, adding, subtracting, multiplying, dividing rational expressions. So today we're talking about simplifying rational expressions. Whoops, didn't mean to draw there. And also we're going to be talking about multiplying and dividing rational expressions, okay? So let's get right into it here. So an expression is simplified when the numerator and denominator have no common factors. No common factors other than plus or minus 1. And to simplify, we're going to factor the top and bottom, then cancel common factors. I guess I should have talked about what a rational expression is. A rational expression is basically any expression that can be written as a fraction. So 1/2 is a rational expression. 2x over x minus 4 is a rational expression. Rational has the word ratio in it, and a ratio is basically a fraction, okay? So these are all types of rational expressions, okay? So they can be as simple as 1/2. It can be as complicated as having a whole bunch of x to the 5th, that kind of stuff. And so yeah, so today we're going to be talking about just like reducing fractions, kind of like we're reducing fractions, but with more complicated rational expressions, I guess. And we're also going to be talking about multiplying or dividing. But the trick to this stuff is going to be that it's going to be very similar to the properties of fractions, because these are just basically more complicated fractions, okay? All right, it says you may want to have your factoring sheet out to help. So, the factor flow chart is going to be very useful for this. Make sure you talk to me in class if you need a new one. So let's talk about this here. So, number one, we have x squared plus 6x all over x plus 6. So the first thing we need to do is we need to factor the top and bottom expressions as best we can. So, is there a GCF we can plot of top or bottom? Well, on the top, we can plot an x, right? They have a GCF of x. Remember, a GCF, or greatest common factor, is going to be the biggest number and the smallest exponent that they both have in common. So I can plot an x, and then when I divide by the x, I'm going to have x plus 6 remaining all over x plus 6. And here's a trick for you when you're doing these kind of problems, is that usually one of the factors is going to be something like the simplified factor at the bottom here. Okay, do you see how we have x plus 6 and x plus 6 now? Well, these are going to cancel out because they're common factors, and we get that it's equal to x. So it's kind of cheating a little bit, or being kind of sneaky. But if you're not sure what one of the factors is going to be, it's possible that the factors are going to be something that's already in the rational expression. Okay, and there's your first thing. You're good to go. All right. Why don't we, you can try a couple on your own, see how you do, and we'll go through these in a second. All right, number 2, we have x minus 4. We have x squared minus 16 on the bottom. Is there a GCF on top and bottom? The answer is no. Is there, how many terms do we have here in top and bottom? This one's just x minus 4. We can't factor that at all. But the bottom, we have x squared minus 16. What kind of pattern is that? That's a difference of squares. That's the difference of squares, which factors a plus b, a minus b. Whoops. It's the same thing as a squared minus b squared, okay? So that's the pattern we're going to use here. So we're going to keep x minus 4 the way it is over, and what's going to factor to? Well, it's going to be x plus 4 times x minus 4. All right, do we have any common factors we can cancel now? Well, we have x minus 4 on top and bottom, so they're going to cancel out. It'd be just like if we had like 2 on top and bottom, they would cancel out. And now what's left over is we just have, when everything cancels, there's a 1 left over, so we're going to have 1 over, and then x plus 4 is going to be left over, okay? So it's just like, this is a similar thing as if we had 3/6 is the same thing as 1/2. If you reduce 3/6, you get 1/2. Those are equivalent fractions. These are equivalent rational expressions. This is the same thing as this over here. Just by canceling out common factors, it does not change it. It just kind of makes it more easy to use. Okay? All right, let's talk about number 3 now. We have x squared minus 5x minus 6 over x squared minus 1. All right. Well, I have is there a GCF we can plot of either of these top or bottom expressions? No. How many terms do we have on the top? We have 3. Is this general factoring or smiley face method? It is. We need factors of x squared, which is going to be x and x. And we need the middle terms to add up to, they need to multiply to negative 6 and add to 5. What's that going to factor to? Well, that's going to be, we're going to do negative 6 and positive 1. It's going to multiply to negative 6x plus 1x. It's going to be 5x, or negative 5x, which is what we want. And it's also going to multiply to negative 6. So the top's going to factor to, so just review a factoring a little bit, x minus 6 times x plus 1. And on the bottom, what do we have on the bottom here? Well, we have, this is smiley face. On the bottom, we also have difference of squares again, right? So it's going to factor to x plus 1 times x minus 1. And what's going to cancel here? What are the common factors we have here? We have x plus 1s are going to cancel. Those are common expressions that we have on top and bottom, so they cancel out. So we're just left with x minus 6 over x minus 1. And there we go. All right, number 4 is a little tricky. So we have m to the third minus 8, or m cubed minus 8 over 2 minus m. All right, so m cubed minus 8, is that a pattern that we know? It actually is. This is a difference of cubes. So how does that factor? Well, that would be, so we have a cubed minus b cubed is going to be, we're going to do a minus b times a squared plus ab minus b squared. Okay, that's just a pattern that's on your factor flow chart. That should be something that you know. Oops, it should be minus plus b squared though. Sorry, my bad. So let's go ahead and factor this now. So the cube root of m to the third is m. Cube root of 8 is 2. So we're going to have m minus 2 times m squared plus 2 times m is 2m. And then 2 squared is 4. That's all over 2 minus m. Actually, you know what? I'm going to rewrite this. I'm going to write negative m plus 2, and you'll see why in a second here. Okay, I'm going to rewrite it as negative m plus 2. Now, why did I write the negative m plus 2? Well, it looks like the top bottom are going to cancel out, but the problem is that these signs are different. These signs do not match these signs up here, right? So what we're going to do, the way you can fix this so you can cancel stuff that should cancel but has the wrong signs, is you're going to factor out a negative 1. So I'm going to rewrite this. M minus 2 times m squared plus 2m plus 4 all over. I'm going to pull out a negative 1, and that's going to change the sign. So if I divide by negative 1, I'm going to have m minus 2. Do you see how that helps us? If we divide negative m by negative 1, we get positive m. We divide positive 2 by negative 1, we get negative 2. And now these are going to cancel. So now what we have, m squared plus 2m plus 4 divided by negative 1. If we divide those all by negative 1, we're going to get negative m squared minus 2m minus 4. And there's our answer, okay? And negative m squared minus 2m minus 4 does not really divide nicely, so that's going to be our final answer. Okay. Got a couple more to try here. See if you can, I'll leave it here. See if you can try a couple more of these on your own. All right, let's talk about number 5. Let's change our colors here. X squared minus 9 over 2x plus 1. All right. Is there a GCF for top or bottom here, first of all? No. Let's look at the top expression now. Bottom equation, we can't simplify. 2x plus 1, there's no GCF. It's not a pattern that we know. But the top is a what? That's a difference of squares. So that's going to factor to x plus 3 times x minus 3. All over 2x plus 1. All right, does that help us at all? Well, this is reduced or factored, but we can't actually cancel anything because one thing I forgot to mention is that you can't separate and just do like x and x like this and this. That's not going to work. Well, I can't really. If I can't cancel the x and 2x and the x and x plus 3, if there's addition or subtraction around these terms, they need to be kind of grouped together, okay? So this actually is our final answer. We can't do any more canceling here, okay? So you can reduce exact expressions, but you can't cancel parts of expressions. So I can't cancel the x and the x. I have to cancel 2x plus 1 or x plus 3. Okay? All right, number 6, get a little bit more challenging. All right, we have 2x to the third minus 32x over x squared plus 8x plus 16. Okay, is there a GCF we can pull out of the top or bottom? There is. We can pull out a 2x. And then we have, what, x squared minus 16? We divide, and then we have on the bottom, on the bottom, that's actually what's called a, this is called a perfect square trinomial. So perfect square trinomial is a squared plus double ab plus b squared. And that factors to a plus b quantity squared. So this actually is a perfect square trinomial. The square root of x squared is x, the square root of 16 is 4, and double 4 times x is 8x. We know we can do that. So on the bottom here, we're going to have what is x plus 4 quantity squared. All right, are we done? Well, not quite. X squared plus x squared minus 16 can be factored more. That's the difference of squares. Okay, so we can factor that into x plus 4 times x minus 4 all over x plus 4 all squared. All right, can we cancel anything now? Well, we have 1 x plus 4 on top. We have 2 x plus 4s on the bottom. So one of these x plus 4s is going to cancel. We're going to have 1 left on the bottom. So now what we have is we have 2x times x minus 4 all over x plus 4. All right, and there we go. Sounds good. All right, number 7. We have 4x squared over 4x cubed plus 12x. Oops, there's an alarm. Sorry about that. Okay, is there a GCF we can pull out of the top or the bottom? The answer is yes. On the bottom, we're going to keep 4x squared the way it is, but on the bottom, we're going to pull out a 4x as a GCF. And we're left with x squared plus 3. Let me double check that here. 4x, yep, looks good. Okay, can we do any canceling now or reducing? Well, 4 and 4 are going to cancel and go to 1 and 1. And then how many x's are going to cancel there? Well, we have 1 on the bottom. We're going to cancel 1 on top, so we're going to be left with x over x squared plus 3. And there we go. All right, the last one looks really tricky. Number 8, 6x squared minus 4x minus 3 all over 3x squared plus x. Is there a GCF we can pull out of these first of all? No, we cannot. Can we do any factoring here? Well, what we would do, we have 6x squared minus 4x minus 3. There's 3 terms. It's not perfect square trinomial because 6 and 3 are not perfect squares. We would try to do a smiley face method here. Let me just show you real quick here. If we do smiley face method, we need factors of 6x squared, which is 2x times 3x, or 6x times x, and then factors of negative 3 are negative 1 times 3. So if we tried, for example, to get 4 in the middle here, so say we did, 3x and 2x, and we did, let's see, we want to get 4 in the middle. Let's do, well, yeah, I'm just going to try something here. If we do negative 3 and positive 1. If we do that, we're going to get negative 6x, and we're going to get 3x, which is going to equal negative 3x. We were really close, but basically this top one does not factor. It does not factor. It does not simplify this 3x minus 3, 2x plus 1. It's about as close as you can get. So actually that one's going to stay the way it is because we can't do any factoring. That's fine. It's basically prime is what that's called. We can't do any factoring. But on the bottom, can we pull out any GCF or do any factoring? Yeah, we can pull out an x. X is our GCF, and we're left with 3x plus 1. And then, yeah, that's going to be as far as we can go. That's our answer. All right, kind of a tricky one, but that's as far as we can go. Okay, moving on to multiplying and dividing now. This is similar to what we've been doing. It's just one extra step. Let me change my color here. All right, so to multiply, remember, it's, the fraction wrap I teach is multiplying fractions, no big problem. Top times top over bottom times bottom. And dividing fractions, easy as pie, flip the second and multiply. Or with dividing, we think of keep, change, flip. So this is going back to our fraction properties, or multiplying or dividing fractions, but we're going to be doing it with like more complex rational expressions, okay? So let's fill in our blanks here. To multiply a rational expression, we need to factor all parts of the expression and then cancel out any common factors and basically multiply across and then reduce. Multiply across and then reduce. Okay. So that says multiply the rational expressions and simplify the results. So we have 6x squared y to the third over 2x squared y squared times 10x cubed y to the fourth over 18y squared. All right. So we need to do some reducing and canceling here first of all. So I like to just reduce the numbers first of the fractions, and then we can go ahead and multiply everything at the end. So if we're reducing fractions, which way can we reduce? Can we reduce vertically or diagonally or what? I kind of erased what I wrote there. But you can reduce fractions vertically or diagonally, but not horizontally. So what I'm going to do first is I see the 6 and 18. What number goes into 6 and 18 nicely? 6. 6 goes into 6. 1. 6 goes into 18. How many times? Good. 3 times. And then I see 2 and 10. How many numbers go? What number goes into 2 and 10? 2. 2 goes into 2 1 time. 2 goes into 10 5 times. Okay. You could also cancel and reduce the by dividing and subtracting the exponents, but I like just multiply straight across because it's really easy to cancel once they're all combined. So we're going to multiply the numbers, which is 1 times 5 is 5. Then I have x to the squared times x to the third. It's going to be x to the fifth. We add the exponents when we multiply straight across. And then I have y to the third times y to the fourth. It's going to be y to the seventh. All right, and now I have on the bottom, we have 3. It's going to come along for the ride. We have x squared is the only x's down there. And then we have y squared times y squared is going to be y to the fourth. And now we have to reduce and cancel a little bit more here. 5 and 3 don't reduce. How many x's are going to cancel? I have 5 on top and 2 in the bottom. 2 x's are going to cancel. I'm going to be left with 3 on top. How many y's are going to cancel? I have 4 on the bottom and 7 on top. 4 are going to cancel. We're going to be left with 3 on top. So we're going to have 5 x to the third, y to the third, all over 3. And there's our answer. All right. So basically the whole trick to these is going to be factor and cancel. Factor and cancel. Okay? Factor, multiply across, and cancel, I guess, is the moral of the story. All right. If you'd like to try a couple of these on your own, otherwise we're going to go through them really quick here, okay? All right, number 2, we have 3x squared minus 27x to the third. So we're going to factor each of these expressions top, bottom, left, top, bottom, right, and see if we can simplify this a little bit. So I'm going to cross this off. What can we pull out of this top left one here? Well, 3x is a GCF, and what's left? Well, we have 1 minus 9x squared. Okay, how about the bottom left? No GCF, but we can actually factor this. This is going to factor if you use smiley face method. If you do smiley face method, you're going to have 3x and x, and then plus 1 and minus 1. Okay, if you do smiley face method, that's going to multiply the 3x squared and negative 1 and add to negative 2x in the middle. And then over here, this is going to also multiply to 3x minus 1 if we do smiley face, and x minus 1. Okay? So, let's go ahead and do this now. So, we are going to, let's do some canceling first here. So we see we have 3x and 3x. These are going to cancel, 3x and 3x. I also see x minus 1. I can cancel things vertically or diagonally. Okay, so that's what I'm doing. And now I'm going to multiply straight across. So I have 1 minus 9x squared times 3x minus 1. So I'm going to put that. 1 minus 9x squared times 3x minus 1. All over, and then 3x plus 1 is going to be on the bottom. All right, and now I'm not quite done yet. This 1 minus 9x squared, this is actually a difference of squares. So I can do more canceling here, or more reducing. So let's do that. So we're going to do, so that would be, difference of squares would be 1 plus 3x times 1 minus 3x. And then 3x minus 1 all over 3x plus 1. All right, can we do any canceling now? We multiplied across, now we want to reduce and cancel. Well, 1 plus 3x and 3x plus 1, these are the same. These are going to cancel out. All right. So now this is going to equal, we're going to have 1 minus 3x times 3x minus 1. And you can see these are like opposite factors. You see what I'm seeing here? Yeah, so if we rearrange these a little bit and factor out a negative 1, if I flip these around and I pull out a negative 1, that's going to make it 3x minus 1 times 3x minus 1. Okay, I flipped them around. I rewrote this as negative 3x plus 1, and then I pulled out a negative 1. Now I have, if I can reduce this, I can do negative 1 times, I have two 3x minus 1s being multiplied together, all squared. And there's my answer. Okay, tricky stuff, very tricky. All right, let's talk about number 3 now. X plus 2 over 27x to the third plus 8. All times 9x squared minus 6x plus 4. All right. Well, GCF are things we can factor here. No GCFs. This one's not going to be any pattern really, but the bottom left is called a sum of cubes. It's a sum of cubes. This is going to factor to 3x. If you look at your factor flow chart, it'll factor like this. 3x plus 2, and then we'll get 9x squared minus 6x plus 4. Okay? Because remember, it's a plus b times a squared minus ab plus b squared. That's how it's going to factor. Okay? The cube root of this is 3x. The cube root of this is 2. Okay? And now you see what I was talking about before? Now we have, let's rewrite this here. We have x plus 2 over 3x plus 2 times 9x squared minus 6x plus 4 times 9x squared, minus 6x plus 4 over 1. You see how these are going to cancel out now? They're the same. So that's what I was talking about. Like one of the factors when you're doing these will usually be the right answer, okay? And then we're multiplying by 1 over 1 basically, which doesn't do anything. So our final answer is going to be x plus 2 over 3x plus 2. And that's our final answer. All right, we got a few more examples to do here. Okay, so dividing rational expressions. How do we divide rational expressions? We're going to factor all parts of the expression, then use keep, change, flip. And multiply, simplify like usual. Keep, change, flip. So basically you're going to flip dividing fractions easy as pie, flip the second, and multiply, okay? So I would probably, before I do any factoring here, let's just rewrite it right away first. Let's get in the habit of doing that. So we're dividing, we're going to take this, we're going to change it to a multiplication, and then flip both of these. Okay? So 3 over 4x minus 8 divided by x squared plus 3x over x squared plus x minus 6 is going to become 3 over 4x minus 8 times x squared plus x minus 6 over x squared plus 3x. Okay, so now we can do some factoring and canceling here. Okay, can we do any reducing or factoring of 3 or 4x minus 8? Ooh, I think I goofed something up here. You can actually pull out, oh no, we're good. Okay, so on the bottom here we can pull out a 4. So it's going to be 4 times x minus 2. All right, how about x squared plus x minus 6? Well, that is going to factor to x plus 3 times x minus 2. And on the bottom, we can pull out, this is going to factor to x times x plus 3. Okay, yeah, that's fine. All right, so let's rewrite what we have here. We have 3 over 4 times x minus 2 times x plus 3 times x minus 2 over x times x plus 3. All right, we have them all factored now, and now we're going to multiply across and cancel things that are in common vertically or diagonally. What's going to reduce here? Well, I got x plus 3 and x plus 3's are going to cancel, and I have x minus 2 is going to cancel. Now I can just multiply straight across, so 3 times 1 is going to be 3 on top, and 4 times x is going to be 4x. And there we go. All right, we have 8x squared plus 10x minus 3 divided by 4x squared. Like I said, you can try these on your own if you would like. Divided by 4x squared minus x. Put this over 1. All right, so we'll reduce, or we'll factor first, and then we'll flip it in a second here. Okay, so let's reduce this first. So this is going to factor. If you do your smiley face method, this is going to factor. The way it's going to factor is 2x plus 3 and 4x minus 1. And over here, this is going to factor to x times 4x minus 1. All right. So let's rewrite this now. Now we have 2x plus 3 times 4x minus 1 over 4x squared times, change flip. Oh, on the bottom is going to be, we're going to put 1 on top over x times 4x minus 1. All right, anything going to cancel here? Yep, 4x minus 1s are going to cancel. Multiply straight across, we're going to get 2x plus 3 on top over 4x to the third. And there's our answer. All right, last example for today. Sorry for the long lesson. It's just kind of a lot to cover. All right, this one, 16xy divided by 3x to the 5th, y to the 5th, divided by 8x squared over 9x, y to the 7th. All right, so let's rewrite it. We're going to rewrite it. Keep, change, flip. 16xy over 3x to the 5th, y to the 5th times, then we're going to flip them. 9x, y to the 7th over 8x squared. Okay, let's reduce some fractions now. Can we reduce 16 and 8? Yep, 8 goes into 8 once, 8 goes into 16 twice, 3 goes into 9 once, 3 goes into 9 3 times. We can multiply straight across now. 2 times 3 is going to be 6. X times x is going to be x squared. Add the exponents. Y times y to the 7th is going to be y to the 8th. Over, on the bottom, 1 times 1 is going to be fine. X to the 5th times x to the 2nd is x to the 7th. And then we have y to the 5th. It's going to come along for the ride. All right. Anything going to reduce or cancel now? Well, x squared, we're going to have 2 x's cancel. We're going to have 5 x's on the bottom. 5 y's are going to cancel. We're going to have 3 y's on top, which is going to be 6 y to the 3rd over x to the 5th. And that should be our answer. All right, a lot of stuff to cover today, but basically it's just factoring and canceling, So, and you can cancel vertically, diagonally, just not horizontally. And also when you divide, you just got to keep, change, flip. You got to change it to multiplication and then flip the second fraction and then do what you were doing before, okay? Thank you for watching. Have a great day, and we will talk soon.